Sri Sai Ram. Hearty welcome to Sathya Loka Seva Gurukulam. In the previous class, we have seen about motion and this description. Let us just continue with that with some more information, right? So, before that, we shall see what you have seen in the previous class. We have seen the importance of motion in daily life. So, any body cannot be at rest all the time. It has to move from one place to another. Wind also moves from one place to another. Water also moves from one place to another. Vehicles also. You cannot keep the vehicle throughout the year in a place. You should make it move, then only it is useful. Like that, the motion is very important in our daily walks of life. And also we have seen about displacement. It is the shortest distance between 2 points. And we have seen that there are 3 kinds of motions. Rectilinear means going in a straight line. Rotatory means circular motion. Oscillatory means swinging motion. We have seen the beautiful examples also. There are the different kinds of motion. Also you have seen that motion is relative. Means there should be one observer and then only we say the entire body is moving in the view of the observer. Therefore we call it as relative motion. And also we have seen the graphical representation of distance travelled and displacement. Is it not? So what is graphical representation? You have 2 axes. One is called x-axis, another one is called y-axis. The point at which we start is called origin. So that's already you have seen. Difference between distance travelled and displacement. Distance travelled cannot be 0, whereas displacement can be 0. Because if a body starts from a point and come back to that point again, we say displacement is 0. And distance travelled is a scalar quantity, there is no direction. Whereas displacement has a direction. Is it not? So these are the things we already studied in the previous class. Let us just go through the homework. First question, an object has moved through a distance. So here an object is there, it has gone to a distance of b. So this is called the starting point, that is called the ending point. Is it not? Can it have a 0 displacement? Yes, it can have a 0 displacement. Give an example. This is an example we are showing there. A body at a point A goes to a point B and comes back to A. From A it starts, go to B and come back to A. You also go to school and come back to school. Come back to your home. What happens? Displacement will be 0. Distance, going to school one distance, coming back same distance. Sometimes it may vary also. So, but displacement is 0 there. So, distance travelled by the body is AB going to school. Suppose this is your house, this is your school. AB is one distance, 2 motion. And fro motion, after a bell is over, you come back to your house. So that is a reverse motion. That is called distance, AB plus BA. But displacement is 0 because you have come back to the same position. So this is an example for that. So you can give many number of examples like this. That is the first question. Second question, an object is thrown vertically upwards. Say some of you are good in games, na? So what do? You throw the ball up and you are going to catch it again. So to a height of say 20 meters, means something like 60 feet, around 60 feet, comes to your hands in 10 seconds. So displacement of the object is, so goes up, comes back to your hand. So answer is 0, because the ball which has thrown out from your hand has come back to your hand again. Therefore displacement is 0. And let us see some more interesting items today. First one is uniform and non-uniform motion. You heard this word uniform, right? All of you will have uniform for your school. Is it not? Why uniform? To show that all students are alike. Girls will have one uniform, boys will have another uniform. To show that we all belong to the same nation. To start with, to the same school. Is it not? So that is what is called your school uniforms. Similarly, motion also you have uniform motion, and some of them will not have that uniform. They will have some color dress for some purpose, and then you have non-uniform. Similarly, motion also, let us see what it is. And also we are going to see about speed and velocity, and then about average speed and velocity. Lastly, we will see some problems on speed and velocity. These are the things of today. As you go to a hotel, what they do? They give you a list that is called menu. You will choose this item I want, this item, this type of juice, this type of ice cream, all that you give. And that supplier will bring to you. Is it not? So you select items. So also these are the like a menu of today. But here there is no question, you have to select all the topics. So here first one is uniform and non-uniform motion. The motion in which an object covers equal distances in equal intervals of time. So for the same time, equal intervals means same time, same distances are covered. Suppose you are in a village. From village you go up to highway. Some single road will be there. You cannot go fast because it is a village road. You have to go slowly and steadily. But once you reach a highway, you can cover equal distances in equal intervals of time. Say you may start with 60, 70, 80, 90 like that. But at certain point of time you can keep the same speed. That is what is called as uniform motion. And the distance covered by object is not equal, means changes. As I told just now, when you are going from the village road up to highway, the speed will be slow, will be less. Once you reach the highway, it will be fast. Once you reach the city, again you have to slow down. There will be signals, there will be traffic jam and so on. You cannot say that I am so and so important person, leave me, nothing doing. All have to wait for the signal, except ambulance. For ambulance only they will permit because it is emergency case. Otherwise, all should follow traffic rules, right? So that is what is called as non-uniform motion, not having uniformity. So this can be shown by a graph also. As I told in the previous class, a graph will have two axes. One is called x-axis and this is called as y-axis. In x-axis we have to take time in seconds, 5 seconds, 10 seconds for every centimeter. This is what is called scale. In x-axis we take the scale as 1 centimeter is equal to 5 seconds. That is the scale we take. That is in x-axis. Okay. So this is the scale, what you say. And coming to y-axis, 1 centimeter is equal to, say if this is in kilometers or meters, is in meters. So 1 centimeter is equal to 4 meter. How you have selected it? Depending on the convenience. For example, here you have 36 meters. That cannot be shown. Therefore you must make it smaller. How to do it? By taking a suitable scale. So this here you see, this you must go on marking for 5 seconds. This position will be here. It covers say 3 meters. For 10 seconds, 4 meters. 15 seconds, say something like 6, like that. So this is a uniform motion. Object A, uniform motion. In object B, the motion go on changing, means up to 10 same, after 10 seconds. After 10 seconds, there will be variation in the speed or cover position, and therefore we will have there will be slight deviation in the graph. What does it show? This shows that it is a non-uniform motion. The straight line shows it is a uniform motion. So this is what is called as graphical representation, which gives a correct image of the motion. Okay. So same thing in a table form, if you put it, time in seconds, that is what you have taken in x-axis, and the position of A, there is a particular body which is in motion, covers 10 seconds 4 meters, 20 seconds 8 meters, and so on. And position of object B, that will be for 10 seconds same. After 10 changes. So it was 8 here, it became 12 here. So there is a change in the motion. That is why it is called as non-uniform motion. So they start at the same time, but object A has the same rate of change of position, whereas B a different rate of change of position. And therefore the graph will be straight line in the case of uniform motion. There will be a uniform motion, but it is not straight, or it will be a little bent in the case of non-uniform motion. That is a graphical representation of uniform and non-uniform motion. Is it okay? Okay. Now what is this beautiful figure you see here? Come on. It is called as odometer. O-D-O-M-E-T-E-R. Now where do you see it? You can see it in cars or buses, tractors and so on, right? So what does it show? It shows the speed of the vehicle. So here starts with 0. This is called pointer. This shows how many kilometers it has covered, and this shows kilometer per hour, speed of the vehicle per hour it shows. So once you start the vehicle, this also start moving. It shows fluctuation. When you go to highway, it will be 80 plus. In a village road, it will be 20, 40 in that range. is it not? So this is a, how many of you have travelled in car or bus? Of course, there is no one which has not travelled in car or bus, right? Everybody has gone. By which do you measure the speed of the vehicle? So there you use what is called as odometer. Can you tell any other device like that? Your thermometer. What does thermometer do? That shows the temperature of the body. You heard about barometer. What does it show? It shows the pressure of the atmosphere. Is it not? So like that we have so many meters. And also you have hydrometer, which tells about the density of the substances. Here you have odometer, which shows the, of course this is the maximum speed a car or a bus can go. Usually it is dangerous to go like that. Always make it one standard. That is, you should not go beyond 120, because you may ask what happens. Suppose you put a brake, suppose a dog or a cat or a sheep or something comes in the middle. You put brakes, it won't stop, because 120 kilometers means it will take at least some more time to come to rest. Is it not? It won't come to rest. So what happens in that position? It will graze or it will smash on the particular animal or a vehicle or whatever it is. Whereas if you are in control, you can put a brake and stop it at that moment, right? So that's why you are not supposed to go more than 120 kilometers. 120 is the maximum. Best and safest is 60. What are you telling? Nowadays is Josh. Especially youths will be telling, you want to go minimum 100. Of course, if you have control on the car or vehicle, you can go up to 100, 120. Otherwise, better to be safer side. That's what Baba says. Start early, drive slowly, reach safely. You must always start early. And also, you should not go in hurry. Hurry makes you worry. So, and also that's why you can reach safely, right? Now, we're coming to speed. Speed is one physical quantity. It's defined as the distance travelled by a body, very important, in a unit time. How is the distance measured? The distance is always measured in terms of meters. How is the time measured? In terms of seconds. So, meters per second. The unit of measuring speed is meter per second. The other commonly used unit is kilometer per hour. Usually vehicles, we say kmh. When you buy a new vehicle, you ask what is the speed it moves. They tell in terms of kilometer per hour. So 1 kilometer per hour means how much? 1 kilometer means 1000 meters. 1 hour means how many minutes? 60. 1 minute means how many seconds? Into 60. So 1000 by 60 into 60 comes to 5 by 18. I think you know how to calculate 1000 by 3600, right? 60 into 60. So 0, 0 cancels. So 2 5s are 2 18s are. That's how you get this. Okay. And same thing, the speed can be shown in terms of distance time graph. The graph drawn for different distances travelled by the object with respect to time is called as distance time graph. So this formula, if you want to write, speed is equal to d by t. So as d increases, s also may increase. So if t increases, s will decrease. If t decreases, s will increase. Like that, there are the three quantities which are connected to each other. And the graph will be like this. Your time is taken on x-axis. As I told earlier, you should have a proper scale. Distance is taken in a y-axis. Here scale is 1 centimeter is equal to 2 seconds. So 2 centimeter 4 like that. Here 1 centimeter is equal to 4 meters. 4, 8, 12, 16, all multiples of 4. Okay. So here you go on marking. So what is the formula for speed? Formula is distance by time. So when you come to 2 seconds, the speed will be here. Is it not? 4 seconds, speed will be like this. So this you just join it and you get a straight line. So what does it show? This line OA represents speed, right? So speed is equal to distance by time, d by t. Okay. So this is what is called a graphical representation of distance versus time. So the distance traveled in 10 seconds is 22 minutes, 22 meters. Speed of the object becomes 22 by 10, 2.2 meter per second. Slope will be AB by OB. So that is how you measure the speed using graph. Now second question, an object moves along a rectangular path of length 40 meters and breadth 20 meters. And it takes about 30 minutes to complete 2 rounds. What is the speed of the object? So speed is equal to distance travelled by time taken. 2 into L plus B. Why you must write 2 there? Because 2 rounds it is given. 1 round is L plus B. I think all of you know what is rectangle. Rectangle is one which has 2 lengths and 2 breadths. Which is bigger? L or B? L is bigger, right? What are the angles? All angles will be 90 degrees, right? So here length is given to be 40 meters. What is breadth? Breadth is given to be 20 meters. It takes 30 minutes to complete the rounds. 2 rounds. So what is the speed they are asking? So first you must know what is called as perimeter. To go on round means how much? So you have 2 into L plus B, 2 into 40 plus 20. So 40 plus 20 is 60 into 2, 120. Is it not? 1 round 120 into 2 becomes 240. So this will be 40 plus 20, 60 into 2, 120 into 2, 240, right? Divided by time 30 minutes. 1 minute means how many seconds? 60. So 240 by 1800. So if you simplify, it will be 24 by 180, and if you simplify it say by 12, 12 2s are 12 15s are. That is how you got 2 by 15, right? So that is the speed. And now coming to the next topic called as velocity. So rate of change of displacement. That it was rate of change of distance travelled of a body is called velocity. It is measured in the same unit as speed, meter per second. Only change is here. Velocity is displacement by time. It is also equal to change in position by time. So that is how a speed velocity is measured. And difference between speed and velocity, speed is a scalar quantity, whereas velocity is a vector quantity. What are scalar quantities? Scalar quantities have no direction. See, birds are flying, you have seen. They have no direction. Sometimes they go from east to west, sometimes from west to east, move upwards, move downwards, and so on. No direction. Whereas velocity means we have direction. One beautiful example is aeroplane. If you want to go to Chennai from Bangalore, which direction you must go? You must go towards east direction. Something like 360 kilometers, let us suppose. So the flight starts from airport Bangalore, moves eastwards. After coming to Bangalore, the same plane want to go to Mangalore. So Mangalore and Chennai are in the same axis. But Mangalore is in which direction? Western direction. So one goes to eastern direction. For Chennai, you want to go to Mangalore, you must go to western direction. But there is a direction. So that's why you can say all velocity is speed. But all speed is not velocity, because velocity has a direction, speed has no direction. So let us work out one more problem on this. So there is a difference between the two. It has got, velocity has got both magnitude and direction, whereas scalar has got only magnitude but no direction. For example, one problem will work out. A rectangular field of side 60 and 80. So 60 means it becomes breadth, 80 means length. Two farmers start moving from the same point to the same, take the same time, that is 30 minutes, to reach a point which is in a diagonally opposite direction. Find the velocity and speed of both the farmers. You have to find out speed also, you have to find out velocity also. Okay, let us see how to do it. So this is a field, length is 80 meters, breadth is 60 meters. Here are two farmers. Farmer A start to moving, go in this direction towards western direction, eastern direction. Okay, goes to east and then comes to south, and that will be what is called as speed, you can say. And here starts, comes in this direction, straight like this. Now you are asked to calculate speed and also velocity. There are two farmers. So Pythagoras theorem you have to use, because in a Pythagoras theorem, in a right angle triangle, which is the longest side is called as hypotenuse. So here 60, this is 80, and suppose you call it as ABC. How to apply Pythagoras theorem? AC square is equal to a right angle triangle. Square on the hypotenuse is equal to sum of the squares of the other two sides. That is how you use it. So, suppose you take AB, that is 60 square, and if you take BC, 80 square, then you know 60 square is 3600, BC square is 6400. If you add it, you get 10,000. Square root of that is 100 meters. That is the hypotenuse, or in a rectangle it is called as diagonal. Coming to velocity, velocity is the rate of change of displacement. So, it will be displacement by time. Displacement is 100, by this formula you have found out now. Time taken 30 minutes means how many seconds? 30 into 60, 1800. So, it is 100 by 1800. So, 100 cancels, you get 1 by 18. That is the velocity. Coming to speed of A goes towards eastern direction, then comes south. So, distance travelled is 80 plus 60. So, 80 plus 60 means 140 by 30 minutes, 30 into 60, 1800. So, if you divide, 0 cancels, you get 14 by 180. So, that is the speed of A, farmer A. Speed of B, he goes like in a diagonal, because he is very clever man. You want to go the shortcut. So, how do you get 100 here? This is 100. So, 100 by 30 into 60, that will be 0 cancels. We have 10 by 180, again 0 cancels, you have 1 by 18. So, what do you observe here? You observe that velocity of both forms are same, whereas speed will change. Speed of farmer A is 14 by 180. Speed of farmer B is 1 by 18. So, that is observation. You can appreciate the velocity of both the farmers is same, but speeds are different. I don't know how many have the habit of appreciating others. Always you should appreciate others. You do it. Suppose some A team and B team are playing, say volleyball. If A team wins, you must clap and support, appreciate. 100 meter race, your friend, of course all your friends only. Suppose A wins there, but appreciate. Once draws a diagram, drawing, but appreciate. Okay, that appreciation is a very good human value you must develop in life. You try to encourage others for their goodness, that gives credit for you also, and that gives encouragement for others also, right? So, this is the problem connected to that. Now, coming to the next topic called average speed and average velocity. Why that average comes? As I told earlier, the speed go on changing from place to place, from time to time. So, you have to find out average. Even your test marks, you do average, right? Kannada so much, English so much, all are not equal except in a few cases. So, all marks will change. What the teacher do? He says average they take. Add all the marks, divide by number of subject, that gives average. Is it not? And that similarly you have average speed means total distance covered by total time taken. Average velocity means total displacement by total time taken. For example, a player completes his half of the race in 60 minutes and next half of the race in 40 minutes. Totally if he covers 1200 meters, find his average speed. So a speed will be total distance covered by total time taken. 1200 is the total distance divided by 60 plus 40. So many minutes. So 100 minutes means 100 into 60, that is 6000. If you simplify it, it becomes 1 by 5 meters per second. So that per second will be written as -1. Okay, I think most of you have understood this. That is what is called as average speed. Now one more sum. If an object moves 30 meters towards north in 10 seconds, it is an object called C towards north. So this is a point here, origin, north. That is how we show in a map. Come on, you stand up in your place, show me the direction east. How do you find out the directions? Wherever you go, no, you must see in which direction the sun is. Sun rising point is called as east direction. And if you face the sun, left of the sun rising is called as north. Right of the sun rising is called as south. And back of the sun rising is called as west. So be careful. Wherever you go, you must know which direction you are moving. Suppose you are in a bus, suppose you are in a train, suppose you are in a flight, you should know which direction you are moving, right? So here is a question. Here is an object called C which moves northwards 30 meters and then he moves eastwards 40 meters. And they are asked to find out average velocity, means you have to find out displacement. Again, by using Pythagoras theorem, BC square is equal to AB square plus AC square. So 40 square plus 30 square, that will be 1600 plus 900 become 2500. BC is 50 meters. So this becomes 50. That is displacement. Now question is, you have to find out velocity. How to find velocity? Displacement 50 by total time taken. 10 plus 10, 20 seconds. So 50 by 20, that will be 2.5 meters per second. That is the average velocity. Okay. So one important point you must note, average velocity is less than or equal to average speed. If displacement and distance become same, this will be same. Velocity and also speed become same. So average velocity can be 0, because if displacement is 0, then velocity also becomes 0, but not average speed. Okay. And in the case of circular path, if the object comes back to the starting point, displacement is 0, hence average velocity also 0. For example, if you are running in a circular path, you come to the same point from where you started, there we say displacement is 0. Okay. So this is what you can learn from this, or conclusion of that. Now coming to home assignments. First question, a cyclist moves along the path shown in the diagram, takes 20 minutes from point A to point B. Find the distance, displacement and speed of the cyclist. From A starts, comes here, that is towards east he moves, then comes south. So what is the distance traveled, what is the displacement, what is the speed of the cyclist? Okay. First question. Second question, a train has to cover a distance of 1200 kilometers in 16 hours. First 800 is covered in 10 hours. What should be the speed of the train to cover the rest of the distance? Find the average speed of the train. Okay. That is the first question. Second question. Third one, distinguish between speed and velocity, which I already discussed now. Fourth one, under what conditions magnitude of average velocity of an object equal to average speed. Okay, come prepared. Thank you.